Hey guys, it's Josip. I'll be filming videos on the Paradigm CTF challenge from 2021. It's kind of an old challenge, but it's known to be like notoriously hard. So I also decided just to challenge myself, try to solve these challenges, and then create videos on them. Basically, there is like a repository which contains all of the challenges. You can easily find it. There are also solutions to each of these challenges, but I encourage you. I went through the thought process myself to challenge myself to basically try to crack the challenge. So I encourage you to do the same. And if it doesn't work, check out my solution, or there's a bunch of other solutions on the internet. So we'll be going through the bouncer challenge. So basically, the objective of this video is to present you what is the bouncer challenge. So how does this system work that you're supposed to exploit? It's actually a single smart contract. Then and what's kind of the objective? So how do you what is the criteria for having the challenge solved? Also, we'll go through possible attack directions. So here I will kind of tell you at what points in the contract I was looking at, how did I try to exploit it, and then we'll check my solution. I've created like this simple test by using the Foundry framework, which kind of solves the challenge. So let's actually go to how does the system work. So basically, we'll be switching between these diagrams and the code just to show you some details. So basically, the bouncer contract is a pretty straightforward and simple contract, and it has the following functionality. So let's actually jump to the contract just to show you. So it has this enter function. So enter function allows anyone to, by paying this entry fee, which is one ETH, to express their intention to basically convert any token of their choosing through the bouncer contract. So what you do is you pay the entry fee of 1 ETH, and then you push kind of an entry to this entries mapping, whereby you specify the amount of some token, you specify the address of the token, and also here we kind of write the block timestamp at which this was executed. So it's just a way of expressing your intention through the bouncer contract. I want to convert this amount of this token, which kind of leads us to the second functionality. The second functionality is the conversion process. So previously in the entry function, you specified some amount of some token. Then in the convert function, in the internal implementation of the convert function, you're actually transferring the amount of that token you have previously specified into the bouncer contract. If it's any ERC20 token of your choosing, we check the allowance, and we here in the proof of ownership, we transfer it from your ownership to the ownership of the bouncer token. Or if you've specified it, you're just kind of directly transferring it to the bouncer contract. And then the third main function is once you've entered, once you converted or kind of transferred that token into the bouncer contract, you can just redeem it back. There is some like other functions where you can kind of delegate, someone to kind of basically you can delegate someone to convert on your behalf. You can remove that delegate, and there is some like managerial functions, but they are only executable by the owner of this bouncer contract, and the owner is set inside the constructor. Also, there is this function you can kind of convert a single entry, or you can convert many entries. So let's kind of reiterate what the system does. It's a pretty basic system, and in my opinion, it's kind of useless. It doesn't do too much. So you pay this entry fee just to transfer some token into the contract and then transfer it back. So as we said, you express your intention by entering, pay 1 ETH in entry fee, and specify any amount of any token. Then by using convert or by batching multiple entries by using convert many, you basically transfer that ERC20 token into the bouncer contract. So this ERC20 token can be, as I said, any ERC20 token, or it can be ETH. And then the final step is you redeem basically through the bouncer, whereby this ERC20 token or ETH stored in the bouncer contract, which belongs to you, it's basically transferred to the user or basically to whomever you have specified. Okay, so that's kind of the basic functionality of the system, and it's being kind of set up in a specific way. So it's being set up in a way that initial balance of the bouncer contract itself is like 50 Ether, and then you have a kind of two entries by this setup contract. So initial balance is actually like this 50 plus these two, so there's 52 Ether. And the objective of the challenge, so you need to drain the bouncer balance. So after you exploited the contract, the bouncer balance should be 0. Remember, the bouncer balance allows you to enter with any ERC20 token, but it also allows you to enter with Ethereum. So you can kind of send 5 Ether there and then transfer back those 5 Ether. So kind of the objective would be to transfer a certain amount of Ether, but kind of pull more Ether than you can transfer. Actually pull all of the balance of the bouncer. So basically, initially when I start solving a challenge like this, I try to kind of pinpoint what are the issues in the contract, which functions are public, what are the inputs to each function, and how can you in a way manipulate functions. Based on that, I'll kind of eliminate some functions. So these functions are payable. I just kind of eliminated them from the beginning. Also, like removal of delegate didn't seem too interesting. This add delegate kind of seemed interesting, but in the end, it turned out that you cannot do anything with it. So first, I kind of eliminate a couple of functions. and then I start checking the other functions, and my main area of focus, and I have to be honest, I spent too much time on some of the points, and then in the end it turned out that this was just like a bait, you know, that the creators of challenge have set up, that you couldn't actually exploit some of the points which in the beginning seemed, you know, exploitable. So I kind of focused on this convert function, and let's get like back to the drawing board, and let's kind of check the, okay, not to show you the solution. Let's kind of check the convert function, what it does. So in the first step, you specify an entry. You specify one or multiple entries where you express your intention to convert some token through this bouncer contract. So in the convert function, this entry is being read from storage, and then we first check, you know, is the entry token ETH or not. If it's not ETH, we check, since this convert function will actually try to transfer, you know, token in your ownership to the bouncer contract. Here it first checks if the allowance is given to maximum to address this to the bouncer contract, and then down below it kind of tries to transfer from, and there is this kind of checking if the transfer from just returns, you know, true. So this doesn't revert, but it doesn't actually check the balance of the bouncer, and it doesn't check if these tokens have actually been transferred to through the bouncer contract. Also, immediately, as you see, if some like arbitrary token, if you're calling some arbitrary function from an arbitrary token or arbitrary contract in your contract, and your contract is not doesn't have this no reentrancy modifier, it means that this function and this function can kind of call your function any number of times, or easier said, it's kind of you've allowed the reentrancy. So how does it work? The bouncer will call the allowance function on any kind of ERC token you've set up, and then the ERC20 token can just, you know, return the allowance. It can have that type of implementation, but it can kind of call back the bouncer contract, and it can use both call or delegate call. The difference is, if you're using call, then the context will be the bouncer contract. So you're actually like manipulating the storage of the bouncer contract. If it's delegate call, you will just be executing some like functionality which is in bouncer in the context of your ERC20 token, and manipulating the storage of your ERC20 20 token, which I also kind of explored in depth. You know, can I somehow manipulate this by using delegate call? But there isn't much you can do. So once the bouncer calls the allowance function in the ERC20 token, yes, you can, you know, delegate call into this contract, but you're actually not doing anything inside the bouncer. You're just executing it inside your contract, which doesn't do much. And also just calling, you know, re-entering the convert function also didn't do much. So again, I encourage you, you know, to explore the scenarios by yourself. But this is a pretty tight function. You know, it updates everything at the end. it has this like clear distinction between ETH and actually non-ETH. So an ERC20 token and an ETH token, or in other words, if this entry token is ETH, it explicitly requires you to send actually that message value which you're going to write as your entry. So you cannot kind of send like 5 ETH here and write, you know, more ETH here. So it was pretty tight, tight system, and actually nothing could be done by using reentrancy. And again, I've spent like a bunch of times just trying reentrancy with like first using ETH, then using non-ETH token, then using ETH again, or any kind of any combinations with this, but it simply didn't work. So obviously that wasn't the solution. And okay, I'll actually show you what's the issue with the contract. So besides the convert function, which is very tight, and it's like public, both the proof of ownership and convert are public functions, so they can be like called independently. There is this convert many function, and what this convert many function does is it kind of batches multiple converts. So let's say you specified like entry 1, like entry 2, entry 1 and entry 2, and they can be the same, you know. Your token is ETH, and you have like 1 Ether. Your token is ETH. Actually, you have like 10 Ether. So these are like the amounts you paid, you know, two times the entry fee for these two entries. And then this requires you, if you would go directly to the convert function, first you need to transfer 10 ETH, and then you can kind of redeem them back. And the same from the second entry. But if you take a closer look at the convert many function, it actually like calls this convert in this for loop manner, in kind of a batched manner, and it is payable. So when you're calling convert many, you specify this global parameter which is message value, and in this case it can be 10 Ether. But then basically when you're executing this internal function convert, this, okay, let me just like collapse this. The issue here is that the proof of ownership just checks message value. So it doesn't matter if you're looping like 100 times through this. Each time, just the original to message value passed to the convert many function is being checked, and this is obviously an issue, because you can specify message value of 10 ETH to convert many. You can convert through 2 entries, and this check will pass, you know, both times. But this will be updated to 20 ETH. So basically your tokens which you are able to redeem from this contract will be 20 ETH. And you get the point, you know, if you have like 3 or 4 entries, this would be like 30, and if the amount is like 10 ETH, 30 or 40 ETH. So this is actually the lane in which to manipulate and exploit this contract. Once I realized it seemed like pretty simple and obvious, but it's definitely not. And the solution here would be kind of saving the message value into some kind of a variable, then passing it to the convert function, and then kind of decrementing this value, so it's only being so each internal convert is just using how much it needs to use. Again, we would have to like slightly change the convert function, etc. But you get the point. Maybe the moral of this challenge is, if you're using some like really complicated logic, you have your function, it may be loops through something, then it calls some other internal functions, and it's a pretty complicated logic. Just be careful if you're relying on the message value. Okay, so let's get back to our kind of drawing board. So one more time, the issue is convert many has a single message value, but it can call the convert function as many times as it wants, and the convert function just checks in each of these calls if the amount is equal to message value, which allows you to write to that to write kind of to this like storage variable more than you actually have. So this is the solution to the challenge, but there is also some like small complexity after you figure out how to solve it, because you have to drain all of the ETH from the bouncer contract, and there is some math. It's not too complex, but there is some math involved, because initially the bouncer has some balance, then once you enter you add more balance, and then you have to take into account that you indeed have to spend some money to exploit this contract, because you have to first transfer some money but then redeem more than that. The math is not like too complex, but this is how I've kind of solved it. So I basically needed to solve a specific equation. So the equation goes like this. So initially you have some bouncer balance, plus once you enter the number of your entrances, let's say you enter 10 times, the entrance fee is 1 ether. You add like 10 ether to the bouncer balance. Plus, once you do the conversion, you add like more. You add a specific amount you specified during the entrance. You add it to the balance of the bouncer, and then that needs to be equal to to actually like the amount you've specified for each entrance times the number of entrances. And then if you can solve this to the amount for each entrance, you just have to kind of reorganize this equation, and this like leads to the bouncer balance plus time of entrances times one ether divided by number of entrances minus 1. And let's kind of go to the actual to the actual solution. So in order to solve this, I've used the Foundry testing framework. It's quite easy, to set up stuff, to console log stuff, to test out stuff. In my opinion, it's much easier than using Remix or just even maybe like deploying some contracts to the testnet. So forge test test bouncer. Okay, let's kind of shift my face to the right and see kind of what's happening here. Okay, so first we deploy this setup contract. So as I said, setup contract initially funds the bouncer contract with some ETH. Then what we do is we deploy our attacker contract, and I'll show you what the attacker contract does. Here I've just kind of console logged the addresses of the deployed contracts. First, what I was console logging is the bouncer balance before setup. So this is actually 52 ETH. 18. Okay, 50. Okay, I can put it like this. So we have some bouncer balance before ETH. According to that formula, we can enter any number of times. This can be solved for any number of times, but I use like two entrances. Then the setup value is actually like number of times to enter, times like one ether, and that exact amount that you're converting according to that formula is like the balance of the bouncer plus this setup value divided by this number of times to enter minus 1. And in case you're entering 2 times, that amount is actually, let's also divide this. That amount is 54 ETH, which kind of tells us that in order to exploit this contract, in order to steal these 52 ETH, if you're choosing a low number of steps, you have to have some funds, to exploit it, because first you need to enter like 2 times, so pay 2 ETH, plus when you're converting, you need to send those 54 ETH, but then when you will be redeeming, you'll be redeeming like your 50, you will be redeeming all of the balance of the bouncer plus whatever you have sent in that direction. So here I'm using just this like start hoax function from Foundry. This is just actually to kind of pre-fund this attack with some ether. Then we initially like set up the attack. So we enter like 2 times. So the setup attack just like enters with one ether and specifies the amount, which is these 54. So this is like 54 ether. So we have like 2 entrances. After this, we would have like 2 entries inside this like mapping. So this like array would have like two values. Then bouncer balance after setup is like 54 because we've added like the entrance fee is just 1 ETH. So we've added, okay, let's do this like ETH. Okay, so that's after we have entered. Also here, for simplicity reasons, since the bouncer doesn't allow, but this is not it's not a manipulation lane. The block timestamp needs to be different than the entry timestamp, and once you enter, the block timestamp is written. So I've just kind of warped the timestamp by 1 day, or this can be like one second, 1 minute, for whatever. Just so I can execute the attack immediately. The attack, what the attack does is you're sending this value. As I said, you need to spend some money to actually exploit this, and you need to specify the convert many function takes the IDs of your like entries. So you have to specify, since this is like number of entries is 2, these IDs are like 0 and 1. So these are like the indexes in this basically entry array. And what the attack does is just like sends that message value, specifies these IDs, and as I said, you're sending 50 for it, but you're writing inside that like storage like storage mapping, you're writing that you actually have 108 ETH. And then you just proceed by redeeming the whole balance of the bouncer. And what a redeem does is just, checks how many tokens you have. So this will be the whole balance of the bouncer, and then kind of pays you out. So just kind of transfers that ETH into the address of your choosing. And finally the test checks the setup. The setup contract has this like convenience method is solve, it checks if the balance is 0. In our case, the setup is solved, returns true, which means that that we have successfully finished this challenge. Yeah, thanks for checking out the video. Hope that you'll find this useful. Again, if you're using message value and your function logic is really complicated, pay some attention on that. Thanks for checking out, and see you in the next video.